So let's consider a couple more aspects of inheritance and type hierarchies. Let's go back to our code that we were using as a demo. And here's person again. Let's add to this just a little bit. Let's say that what we want to have is a method that is inherited from the base class into the derived class. And let's call it put on close. So let's say that all of our person objects, whether they be person or cowboy or spouse or what have you, they all are required to put on clothes. However, as we go to build the body for this method, we realize that there is no default behavior. We want all of our person objects to be able to put on clothes, but there is no default definition for what that actually means. So instead of giving this thing a body, what we do is we say that it has to exist, but we're not going to specify what code goes in it. So we say abstract. And then this method has no body. Now you'll notice that there's a red squiggle underneath put on close, and the reason for that is that once you put an abstract method in your class, you have to make the entire class abstract, because it's not possible to instantiate an object of this class as one of its methods is missing. And further, all of the derived classes are now in need of a definition for put on close. So we can add those. And once again, we use the trick in Visual Studio of typing in the override keyword, and that gives us the list of all the possible overrides. And of course, put on close is one, because not only can it be overridden, it has to be overridden. And similarly for the other classes. So the difference between a method marked virtual and a method marked abstract is that a virtual method has a default definition that can be overridden or extended. An abstract method does not have a default definition. An individual derived class must decide what that method does. Note also that we can do the same thing with properties. So here we have the abstract property name, and I'm not specifying that get has no code in it. I'm specifying that it has to be determined by the derived class. So now each of my derived classes would require a name property. There would be no default for that name property because the name property in the base class person is abstract. And further, I'm specifying that there is no set part for this property. You'll note that Visual Studio uses lambda syntax here, so it looks a little bit different than the properties that we've been creating. Using this syntax, this is the definition of the name property. I'll create another one for spouse and use the more traditional syntax. Because our base class now includes at least one abstract piece of code, in fact two, it can no longer be instantiated. And so the class itself is marked abstract. Now let's return to our main code and see how it has been affected. And as we might expect, person is now an abstract class and therefore cannot be instantiated. So any places where I'm instantiating person have to be commented out, as you cannot instantiate a person. However, note that you can still use person as a base class, as we're doing here with our array or with our for each loop. So you can create reference variables of class person, but when you instantiate them, they have to point to instantiatable or concrete classes. Now let's move on to interfaces. Let's go back to our person hierarchy code and let's add an interface. Now this is not a class, it's an interface, and there is a keyword for it. And let's call this one communicator. And we will say that all communicators have a certain behavior. So what interfaces do, as opposed to what classes do, is they mandate specific behaviors. For example, here are two behaviors associated with communicators. They have to be able to talk and they have to be able to listen. Now you'll note that there is no access specifier associated with these methods, because all things in an interface are by definition public. You'll also note that there are no fields inside of an interface because it doesn't have any data, it only mandates behavior. It is possible to have properties. So in this case, we say that all communicators must have a property name that has to be gettable and settable. Again, that doesn't mean that that won't have any code in the concrete classes. We're just saying that they have both a get and set part. We then apply this interface to our base class like so. In other words, we use the same syntax as we used for derivation, but in this case, we read this as abstract class person implements communicator as opposed to is derived from communicator. And you'll note that there's a red squiggly line underneath communicator, and what this is indicating to us is that our abstract class person is not properly implementing communicator because there is no talk, listen, or a set part for name. So let's add. Now obviously in my class here, talk and listen have no bodies. That is not to say that they couldn't have, I just don't have a definition for them here. Now let's correct our name property to be in line with what the interface is requiring. And I'm just going to go ahead and delete the whole thing and just type override and see what I get from Visual Studio. And as you can see, it now has a get and a set part. So for get, I will return the name of a field. And for set, I will set that value. And since I'm doing that, of course, I'm going to need a backing field. And that would be the Lambda syntax version for that property. And I make the same kind of correction to spouse. With the other kind of syntax. And similarly for party goer. Of course, we also note that the code for the property name is very similar in each of these derived classes. So maybe now that we've learned that, it makes sense to pull that back up into the abstract class and change it like so. And having made that adjustment, we can then go back to our derived classes and once again eliminate as much as possible code replication. So moving back to the top of the file, we see that we have interfaces. An interface specifies behavior. We have abstract classes, which specify structure and data. And we have concrete classes, which can be instantiated. So now that I have my type hierarchy, I can create a picture of that hierarchy, like so, by right-clicking on the file and selecting View Class Diagram. So here we see a picture of our hierarchy with the abstract class person at the top, and then my concrete classes at the bottom, and an indication that person implements the communicator interface. Now I can expand these chevrons and see more detail in each of these classes, and I can also move them around if I need to. And so that gives me an idea of what my hierarchy is, what's inherited from what, and in what way. So that's our exploration of inheritance and type hierarchies in C#.